Now, in this video, we will going to take up uh, how to analyze the Grashof link mechanism when the links are distinct such that when the condition of the link is S plus L is equal to P plus Q, then when the links are distinct, that is condition of S, the link S will be equal to 40 mm, then the link L, that is the longest link, will be equal to 70. Then the other link is 50 mm and Q, one more other link, is 60. So the condition is S plus L, that is 40 plus 70 should be equal to 50 plus 60, that is 110. So 110 is equal to 110. But here the links are distinct. That means the length of the any link will not be the same. All the links are having different lengths. Even in such condition, you will going to get the inversions you will going to get will be the same as in the case of S plus L is less than P plus Q. So now we want to prove that. So how to do that? So first let us go for the link that is the fusion. So first I will go for the shortest link. So which is the shortest link? I have taken 40 mm here. So I will go for the create sketch, click on the front plane. Now I will go for create, go to slot, take the center to center slot, select some center to center slot and give the dimension. Now here I want this dimension to be like 40 mm. So I will go for dimension, take this dimension as 40. Then I want this link to be placed exactly at this center. So that means I will go for the midpoint. Midpoint of this link should be equal to this origin point. Then I want the dimension. This is the radius. Take 10. Once you do that, so this entire link has been fixed. Now we will go for a circle. Again, take the same two different diameters and go to constraint, select equal, click on this and you click on this. Then I will go for dimension, click on this dimension, give the dimension as diameter 10. Then you will going to get both the circle will have the diameter 10. Then come down to constraint, go to concentric, click on this circle with reference to the semicircle. Similarly, with this circle is which is a semicircle. And I will disable the constraints. Then I will go for this select and place it appropriately so that you will be able to create the model properly. So this is how I will be able to create the shortest link having the length of the link is 40 mm. And of course, we are going to assume the thickness of the link as 2 mm. So once you do that, I will go for finish sketch. Then click on 3D. Now you go to extrude, select this profile and give it, since you are going along the direction of the extrusion, you just go to 2 and click on OK. Now once you do that, now I want to write this as the shortest link and I want to have this embossing. So I will go for offset plane, click on this plane and give the dimension. Since you are going along the dimension, along the direction of the uh, arrowhead, you just type 0.2 from the surface, from the surface of the model and just click on OK. Now you go to right plane and see the difference here. You have a gap of, here you can see this is the actual profile and this is the one which we have created. So I will go for that is the offset plane which has been created by 0.2 and then go to 3 dimension and go to sketch, click on this profile and now you go to create, go to text, click on OK, select on this text and you place it and go to Times New Roman and take the font height as 5 and type the shortest link as yes. Okay, and click on OK. Now you go to modify, click on move, select this profile and place it approximate to the center of this slot and go to click on OK. Then go to finish sketch now. Once you do that, now you go for create, go to emboss, click on the sketch profile is this text, and then go to face, click on this face. And since I want the depth as 0.2, you just take 0.2 and say OK. So this is how I will be able to create the first link. So I'll go for appearance. Again, you come down, click on this radius, I'm in red color and say close. Now once you do that, you just go to save, click on save, type link yes. That is the shortest link. I will save this profile. So the first model of this link has been created. Then once you do that, now we will go for the next one. So the next one, what I want is the longest link. L is 70. So to do that, I will just again go for the fusion and I will exit this link model. Now again go to pod design and make this pod design as hybrid and say convert. Then the longest link will be having the length as 70 mm. For that, I will go for create sketch, click on this particular sketch, that is the front plane. Now I'll go for create, go to slot, take the center to center slot, select some arbitrary point and place this. Go to dimension, select this dimension, make this as 70. Then you go to radius, make this as 10. Then I want the constraints, go to constraint, go to midpoint. Midpoint of this center to center slot should be exactly at the origin. Now you go for sketch. I will take two circles of some diameter and go to constraint, select equal, click on this and click on this. Go to dimension, give the diameter as 10. So automatically this one will also be get updated. Then go to constraint, click on concentric, select on this with reference to the semicircle. Similarly, you select on this with reference to this semicircle and say finish sketch and go to extrude, select on this profile and give the dimension as 2 mm. Once you do that, now you will have the link L. I want to emboss the character L there. So I'll go for offset plane, select on this plane, give the dimension as 0.2, OK, and click on OK. Now you go to sketch, click on this offsetted plane, and now you go to create, go to text, OK, click on OK, and you take this and you change the text height. So here it is 5 and I want this to be the longest length, type L and say OK. Now you go to modify, click on move, select on this text and drag this and place it wherever you want and say OK. And then go to finish sketch, then go to 3 dimension and then go to create, go to emboss, click on the text profile, OK, and then go to faces, click on this face, go to select on this profile and click on OK now. Now this is the longest link. Again you go to appearance and make this as yellow and say close. The longest link has been considered. Again I will go for save and I will go for link L, link L and then say save. The next link what I want is P, that is the other link. So to do that I will just go to fusion, again go to part design, make this as hybrid and say convert. Now I'll go for sketch, select on this particular front plane. The dimension what I want is 50. then go to, okay, then go to create, go to slot, take center to center slot, take this dimension, go to dimension, this is P 50, so take this center to center distance as 50, then I will go for radius and give the dimension as 10, okay, then go to constraint, click on midpoint of this center to center slot with reference to this origin. Now I will go for circle, take two circles of some diameter and go to constraint, click on equal, select on this and you select on this and then go to dimension, give the dimension as 10 and then go to constraint, go to concentric, click on this profile with reference to this, then again with this with reference to this and go to finish sketch. Now you go to extrude, click on this profile, give the dimension as 2 mm and then go to offset, select on this plane, give the dimension as 0.2 and click on sketch and take this profile and then go to create, then go to text, click on OK. Now you go to this window. Now you take the value as P and type the character as P and say OK. Then you go to modify, click on move, select on this and place it approximately at the center and say OK. And then go to finish sketch and go to 3D and again go to click on create, go to emboss, select on this text and select on this face, okay, and take the depth as 0.2 and say okay now. So once you do that, go to appearance, then you come down to blue or you take white, this one, and keep it here and say close. Then go to finish sketch and you go to save, click on, so type as link P, link P, yes, okay, link P and say save. Once you do that, now we have the link P. Similarly, I want link Q, which is 60 now. Link Q. Now I'm going to exit this. Again, go to part design. Click on part design. Make this design type as hybrid and click on convert. Then you go to sketch. Click on this front plane and go to create. Click on center to center slot. Sorry. Click on create, go to slot, take center to center slot, select this and you place it wherever you want. And the value of Q is 60 now. So go to dimension, select this and give the dimension as 60. Then go to constraint, click on midpoint, select this midpoint with reference to this. Then go to dimension, give the radius as 10. Okay. Then go to circle, select these two circles and go to constraint, say equal. This circle should be equal to this, that is the opposite directions. And go to dimension and give the dimension of this diameter as 10. And then go to constraint, select concentric, click on this profile with reference to this. Similarly, this profile with reference to this now. Once you do that, now you just go to constraints now, disable this constraint and then go to move and that is you move this dimension so that you will be able to create this model properly. Once you create this constraint with the dimensions and also with the constraints, geometrical constraints, I will go for finish sketch and then go to extrude, select on this profile and give the dimension as 2 and say new body. Okay. Again, you go to offset plane, select on this plane, give the dimension as 0.2, okay, and say okay. Then go to sketch, click on this offsetted plane and then go to create, go to text, click on OK. Now you take this here, okay, and type Q, capital letter Q, and say OK. Now this is the other link, one more link. I will go for modify, click on move, select on this and place it approximate to the center and click on OK, and then go to finish sketch, then go to 3D. Now you just click on create, go to emboss, then you select on this, come down to faces, click on this face and give the embossing depth as 0.2 mm and click on OK. Now it'll go for appearance, okay. Come down to this yellow is over. Now you take blue, okay, and click on close. Now you go to save, then come down to link Q, link Q now. Okay, now one should know that. Now all these links have been created, and now I want to assemble it. So the condition for this assembly is something like this. So once you come down to this, let us take the first one. Shortest link adjacent to the fixed link. So which is the shortest link? So we will consider the shortest link as a yes. Adjacent to this, I will take either P or Q. I will take, say, for example, I will take P is the shortest. Sorry, cancel. I will go to part design, click on this, go to part, go to hybrid and say convert. Either I can take P or Q. So I will take, in this case, link P is 60. So I will take link P as 60 and drag this and place it. One should do that. Now this first one is grounded now. Adjacent to the condition is what? Shortest link adjacent to fixed link. So here in my case, I have fixed the link P. Adjacent to this is the shortest link is yes. I will drag this and I will keep it here. Then I will move this particular portion here. Click on OK. So I want to go for joint. You just click type J or go to assemble, click on J. As you take it on the surface, you can see that all the snapping points are being highlighted. I want the front end of this link that is on the pole and take that pole to be on the back side of this. Again on this surface, if I take, you come down to this and click. Now it is start rotating now. One should do that. I will say OK, then go to 3D here. Now we have this this shortest link. I go to select. Now you can see this is rotating. Then adjacent to this, now the next link is Q. I will take P is already fixed. Now I will take Q now 70. So link Q. I will take this link and you take it here. Similarly, I will take this and you drag this and keep it here and say OK. So now I will go for joint, type J and take this joint or the center of this should be to the back side of this now. So now it has been rotated. So both the links, both the other links will going to have the rotation link. And then again you go to select and you rotate this and keep it here. Okay. And you just rotate this. Once you have PSQ, then I will go for shortest longest link. Now link L. Take this link L and keep it here. Then move this link outside and click on OK and go to joint. Select on the, as even on this surface to take this center point of that hole with reference to the center of this. OK. Now again it will start revoluting with reference to that point. Again you click on OK. Go to 3 dimension. Similarly, you go to joint. Select on this face with reference to this face now. Okay. Then you click on OK. Now we have the all the three things. Now I will just go to joints, go to Revolute, go to element joint relationship. Now you can see that once the link P is fixed, so here this is that one link is been rotating, whereas the other link will be oscillating. So when the link, shortest link adjacent to the fixed link, you have a crank rocker mechanism. Okay. So how do I know that it is having a crank rocker mechanism? You can see here when you just close the relations, that is the joints relationships. Now you can see the shortest link S is been rotating by 360-degree, whereas the other link Q is oscillating from this particular position to here. Again, it goes back. So this is, since it is the link S is rotating by an angle of 360, it is a crank, whereas Q is oscillating with reference to the link P at the other end of the link P. Since it is oscillating, it is that is why it is called as a rocker. So this mechanism is called crank rocker mechanism when the uh, sh shortest link adjacent to the fixed link is there. Then this is the first inversion. Next condition is shortest link is fixed now. That is double crank mechanism. So we have to prove that now. So which is the shortest link? S is the shortest link. Now I will just go to right click on link P and I will go into unground from parent and I will go for the shortest link and I will go for ground to parent and say ground to parent. Now the shortest link is fixed. Now we will go for uh, Revolute and click on animate joint relationships. Now you can see when the shortest link is fixed, both link P and link L both are rotating by an angle of 360 degrees. Therefore, it is called double crank mechanism. When the shortest link is fixed, you will going to get the double crank mechanism. So in this case also, when you animate, you will be able to see that this link P and link L both are the P longest link and the other link is being rotating by an angle of 360-degree. Therefore, it is called double crank mechanism. Then, so this is the second condition is satisfied when the S plus L is equal to P plus Q, when all the links are distinct. That means the length of the links will not be equal. You can see S is equal to here S is equal to 40, L is equal to 70, P is equal to 50, and Q is equal to 60. Here P plus Q becomes 110, S plus L will also becomes 110. Even though the condition is S plus L is equal to P plus Q, there also the inversion obtained is same as S plus L is less than P plus Q. Then we will go for the third link, which is the shortest link is opposite to the fixed link. So we will go for this again. So which is the shortest link? The shortest link is yes. Adjacent, opposite to the shortest link is what? Now we will just try to animate. You can see that is Q. Shortest link opposite to the shortest link is fixed. That's what he means. Shortest link is opposite to the fixed link. So in this case, what we are considering, Q should be fixed. So S will be opposite to that. So if I want to do that, what I need to do is the Q. I want Q to be grounded. So I'll just right click on link S, unground from parent, and I will go for Q, right click and ground to parent. Once you do that, so now the link PQ is fixed. Now we will see how this will going to be rotating. Now I will just go to Revolute, click on animate joint relationship. Now you can see since the uh, opposite to the shortest link is fixed. So what happens? The one end of the link L and the another end of the link Q. Sorry, one end of the link Q, that is L, and the other end of the link Q is P. Both are oscillating with reference to this link Q. So here, since both are oscillating, that is why it is called double rocker mechanism. So shortest link is opposite to the fixed link. Double rocker mechanism will going to be exist. So that is what we are proving here. When the uh, short shortest link is opposite to the fixed link, then both the link L and Q or both link L and P are oscillating with reference to the fixed link Q. So since it is oscillating, that is why it is called the double rocker mechanism. And hence, even though the condition is express L is equal to P plus Q, when the condition where all the links, the length of all the links will going to be of distinct, then even though the length of all the links are distinct, then it will also satisfy the condition as that of S plus L is less than P plus Q. So this is how we can be able to prove our we can be able to prove the condition of Grashof mechanism. Thank you.